Hi, this is David Voss, CCIE 11372, and welcome to your troubleshooting lab for routing protocols. Specifically, you will be troubleshooting EIGRP, OSPF, Redistribution, and BGP. Now, you're going to be given multiple scenarios, but there's a certain methodology we're going to use for each of the scenarios that you will be doing. The first thing that we're going to do is that we're going to you'll see a diagram of the problem. And then we'll get into the lab and we'll actually show you what the problem looks like. From then, you're going to take it from there and try to troubleshoot it. I'll give you time, then you can display a hint. We will display a hint for you, that is. And then we will reveal the underlying cause. And then again, give you more time to look into the issue, see if you can isolate it if you haven't already. Finally, I'll reveal the solution. And then we will actually show you how to program the solution. So I'll be asking you to pause the video quite a bit, and instead of just jumping right into the solutions, you should really try to troubleshoot, obviously. So here's the lab. Here's at least the layer 1 connectivity for the lab. And How to Network has 2 labs that you can log into and use, and they work really well. This is the lab we've used for these videos. And within this lab, we have built our lab infrastructure for both of the troubleshooting videos, for the routing and then also for the switching and then IP services. So here is the lab configuration for actually both videos, and you'll see we've got EIGRP, OSPF, BGP. We've got switching configured as well. At a high level, you can see what we've done. The configurations are available for you for download. So you need to download the configurations, and then they will be labeled the problem configs, and you will install those problem configs. And believe me, when you log into this lab, there's going to be many things wrong, and you're going to troubleshoot them one by one to get this lab working correctly. So this drawing looks like an ideal situation, but believe me, there's a lot of problems that you're going to be introduced to as you troubleshoot this network. So, and eventually you're going to get it working, so everything's working just fine. So let's go ahead and jump in with EIGRP, our first EIGRP scenario. And again, if you need help, go back to EIGRP troubleshooting videos for assistance. So here's the problem. Our neighbor relationship between router 1 and router 2 is not coming up in EIGRP AS24. So you need to go ahead and troubleshoot why router 1 and router 2 have not come up. So I would suggest you pause the video right now, actually, and then go ahead and troubleshoot. We will continue, assuming you've tried to troubleshoot what the problem was. Hopefully you found it, but you can see here on router 2 that it just has an EIGRP relationship to router 4, and that in fact router 1 has no EIGRP relationship, but here we just see one OSPF neighbor to router 4 to router 2, and then on router 1 to router 2 there obviously is no neighbor relationship. So let's go ahead and take a look at the interface. Is the interface between router 1 and router 2 up? And it appears to be so. We're looking at serial 000 on router 2, and then we're going to ping across that link on router 1 over to router 2, and we do have connectivity. So if you haven't figured it out yet, go ahead and pause the video, see if you can figure it out. The link is working fine. Okay, so now if you're back, let's go ahead and take a look at the EIGRP process, and we'll give you a few more hints. Take a look at this, and what I want you to do is it's via the show IP protocol, and what you're going to do is when you do show IP protocols on these routers, it's going to reveal some key information. And go ahead and take a look at the information here and see if you can find the issue. And again, this is definitely a command you're going to want to run, and definitely a command that's going to give you some important information on why this neighbor relationship is not coming up. And on router 2, what we'll do is we're going to do show IP protocol on router 2. And again, remember, show IP protocol shows all the routing protocols, and one of the most useful commands you can use for troubleshooting. It shows a lot of important information, such as neighbor states and filter lists, redistribution, and metrics. So there's a keyword for you. Take a look at the EIGRP metrics on router 1 and router 2. So here's your hint. Well, this is the issue. The EIGRP metric weights differ between router 1 and router 2. So go ahead and pause now, see if you can find that. Where are the metric weights found? Go ahead and take a look in the lab and see if you can find the differences. And you will see here on router 1 and router 2 in the show IP protocol, the metric weights do not match. They need to. And you can see here, metric weight on router 1 is 11110, which is not the default in EIGRP. And if you toy with that, your neighbor relationship will go down. The default is 10100. So we can see the configuration under EIGRP here. Metric weights has been manually adapted. Somebody has changed it. And that is a guaranteed way of bringing all your neighbor relationships down. So under router EIGRP 24, in order to resolve this problem, we're going to change the metric weights back to the defaults, which is 0 for type of service and then 10100. Once we do that, the EIGRP neighbor relationship between router 1 and router 2 will come up because the metric weights will be the same, will be identical. And if you want to do that in your lab, now would be the time to do it. It's good to get hands-on, to take a look and to configure it yourself. Not only for your exam, but surely one of these days you're going to do it on your own network. So here we can see on router 1 that the neighbor relationship to router 2 is up. And on router 2, of course, we will see the same. It will now have 2 neighbors over to router 4 and router 1. Good, so you have solved your first issue. Ask yourself how quickly you figured it out. Did you have to wait till the very end? Did you get it pretty quickly at the beginning? Obviously, as time goes on, you begin to see some things over and over again. You get really good at this. So let's do the second scenario of EIGRP. And let's take a look at this issue. This issue is router 2 and router 4 are neighbors, but router 2 is not receiving any routes from router 4. The administrator from router 2 is saying, I'm not getting any routes from router 4, and I'm expecting to see some. And the router 4 administrator is saying, yeah, you know what? I should be sending some too. So we've got multiple engineers who work on this router. I'm not sure what's going on. So you go ahead and log into router 2, and you take a look at the routing table, and sure enough, we have verified we're not receiving any EIGRP routes from router 4. So I would say go ahead and pause the video now and go ahead and see if you can figure out why that is. Now on router 4, we do show IP protocol, and we're taking a look at EIGRP. And again, key command, we see 2. We have it displayed for router 2 and router 4, and see if you see anything that seems to be out of place, or the reason that we are not advertising. And I'll give you a hint. It is displayed in show IP protocol. So see if you can find it in router 2 or router 4. So if you haven't found it yet, here is the issue. Router 4 is configured as a stub router, which is not necessarily the problem. The problem is it's stub receive only, which means it will receive routes, but it will not advertise routes. Even though the neighbor relationship is up, and even though there's no filter list in place, router 4 is not going to be advertising those routes. So You will see here the EIGRP stub receive only is actually showing up in router 4's show IP protocol command. And if we look at the configuration, we can see that the EIGRP stub receive only is configured on router 4. So what we're going to do is change router 4. We're just going to go ahead and make it a regular stub. And now you can see, eventually you will see the routes from router 4 showing up in the routing table of router 2. The neighbor relationship is up and it's working fine. And there we have the routes from router 4 showing up in router 2. So router 4 is still a stub, but it's not receive only stub. Therefore, it will advertise its routes over to router 2. And now we can see here on router 4, of course, it is a stub, not a stub receive only. So again, you see show IP protocol shows a lot of key information, can definitely be used, should definitely be used. One of the first commands you should run with IGP troubleshooting. Let's go ahead and do our first OSPF scenario. So now we're going to troubleshoot OSPF. And the issue we're facing here is that the neighbor relationship between router 1 and router 2 is not coming up, and the administrator on router 1 cannot figure out why they cannot form a neighbor relationship with router 2. So go ahead, I would pause it now, see if you can figure out why this neighbor relationship is not coming up. So as you can see on router 2, there's no OSPF neighbor relationship at all. And on router 1, or excuse me, on router 2, we'll take a look at show IP protocol. And we do see that on router 2, that OSPF 24 is running for networks 10.0.0.0, 192.168.1.0, has no neighbors. We're just concerned about router 1 right now, though. And we're looking at the interface for router 1 and the interface for router 2, and to see what is going on. So I would focus in on that for now in your troubleshooting. You may want to pause and focus on the interfaces. Remember some of the reasons why OSPF would not come up between two routers. Even though the interfaces are up, there's a specific reason in OSPF, there's a specific issue that causes neighbor relationships not to come up. And I can tell you right here, it's on the page that you're looking at, right on the screen that you're looking at right now. The solution is in front of you. And it has to do with a manual reconfiguration of OSPF attributes. And the issue is router 1 OSPF hello interval is set to a non-default. So somebody has manipulated the hello interval on router 1. And we can see here on router 1 that the OSPF hello interval is actually 3, which does not match router 2. And when you have two different hello intervals or dead timers on the same link between two routers, that neighbor relationship will no longer work. So we're going to go ahead and remove that command so it goes back to default. And once we do that, then the neighbor relationship will come up. And we can see here it's in the process of establishing. We see here that the hello interval, dead timer, and wait are all set to default. So our next OSPF issue that we're going to look at, Router 4 administrator states that his neighbor relationship with Router 2 is not coming up. So he's got a different issue, and we don't know what it is, but go ahead and pause the video now and so you figure out why Router 4 and Router 2 are not speaking to one another, and I'll save you some time and tell you it's not an MTU issue, and it is not a hello timer issue. We can see here on Router 4 that, yep, in fact, there is no OSPF neighbor relationship. And we take a look at the interface on Router 2, which is connected to the frame relay network, and it seems to be working fine. The serial interface for Router 4 seems to be working fine. It should be noted that they're operating over a frame relay network. And I realize frame relay is not exactly the most popular type of transport anymore. But it doesn't mean you won't be asked a question about it. And it doesn't mean you won't need to understand the implications of running traffic over a frame relay network or a network like it. So as we take a look at the serial interfaces for this network, understanding that OSPF is sensitive to the type of network it's running over. So you need to understand what happens on OSPF when OSPF is communicating over different types of networks. And it's very possible the transport method is what is causing the problem. So there's your hint. The transport method, which happens to be frame relay, is causing a problem with communications just by the very nature of what it is. And here's a hint for you. If you look under OSPF, there's something missing that we need. The fact is, Router 4 does not have an OSPF neighbor statement for Router 2, and it needs to in order to communicate over this frame relay network, the way it's configured at least. We need to be able to tell Router 4 to specifically send packets over to his neighbor IP address for Router 2, which is 10.0.0.2. And once we do that, the neighbor relationship will come up. But it's important to note, and the goal of this was just to show you that OSPF simply doesn't work by the fact that you roll it out over any network type. Oftentimes, the specific network you're rolling OSPF out over, you need to do certain things or tweak OSPF in certain ways to make sure that it does work properly. So it often is not an OSPF issue necessarily, it's just the fact that you ran OSPF over a certain network type. And as you can see here, the neighbor relationship has come up between Router 2 and Router 4. So let's go ahead and troubleshoot redistribution from EIGRP into OSPF. And here's the issue. The complaint is that the administrator on Router 2 is trying to redistribute the subnets into, they're trying to redistribute EIGRP routes into OSPF. And the administrator on Router 4 is stating that he's not seeing any of those routes. So one thing we want to do on Router 4 before we continue, go ahead and do a no network 10.0 and remove EIGRP 24 from its frame relay interface, because we want to rely only on OSPF routes at this time. So we should be seeing those EIGRP routes on Router 4 showing up as basically external or OSPF routes. So go ahead and pause the video and figure out why Router 4, for example, is not receiving any routes from Router 1 regarding Router 1 via OSPF, because those routes are being advertised into from EIGRP into OSPF and router 4 should know about them, but it does not. And we see router 2 has an EIGRP neighbor relationship with router 1. So it is learning routes from router 1, and it is learning the routes from router 1. But even though router 2 is aware of the routes from router 1, as you will see in your lab, router 4 is not getting them. So if router 1 is advertising them okay and router 4 is not getting them, you obviously want to focus in on router 2. So within your lab, make sure you log into router 2 and take a close look at the redistribution of EIGRP into OSPF. So let's go ahead and take a look at OSPF now and the redistribute command. Redistribute EIGRP 24 metric 124. Does that appear to be correct? What do you think? The neighbor relationship between router 4 and router 2 is up. Redistribution is programmed. The problem is router 2 does not have the subnets keyword in OSPF redistribution. If you forget that, only classful subnets will be redistributed. This is a common problem in OSPF that people often forget about. And that is, if you forget the subnets keyword, then you will be missing a lot of data. The redistribution will not work correctly. So under router OSPF 24, we're going to redistribute EIGRP 24. And then here is the subnets keyword. Subnets. Very important. A lot of people get tricked up on that with the same metric and tag as we had before. But once we do that, you will then see EIGRP redistributing into OSPF correctly. And router 4 will be receiving all the routes it's supposed to be receiving. And believe me, this is an issue you see commonly if you are redistributing EIGRP into OSPF or anything into OSPF for that matter. Next, let's troubleshoot an issue with BGP. Here you can see we have 3 different BGP autonomous systems, but the problem is Autonomous System 2 is receiving routes from Autonomous System 4, but the path shows as going through Autonomous System 1. And the thing is that router 4 does not have, before we get started, let's go to EIGRP 24. Let's go ahead and enable EIGRP between router 4 and router 2 again. So just type in router EIGRP 24, enable EIGRP on your frame relay interface, and get that up and running. So now we know BGP will work correctly because BGP, the neighbor relationships relied upon that underlying IGP working. So, but note on router 2, it's receiving routes via BGP from router 4. The problem is, as you will see, and what's very odd, the administrator believes, is that these routes show an AS path of 4 and then 1. And it's as if it's going through Autonomous System 1. Now we do have an Autonomous System 1. It's a neighbor of router 2. So the question is, being that router 2 is basically the hub, and router 1 and router 4 are the spokes, why is it that we're seeing this path of 4 and then 1? And is there some sort of loop, or is the advertisement being passed through and then passed back again? You need to figure that out. So I would go ahead and pause your video now if you want. Figure out why AS path 1 is showing up in the advertisements from router 4 over to router 2. And you can see here the neighbor relationship in router 4 over to router 2 is valid. It's up and working just fine. And we're showing our advertised routes. And you can see the routes we're advertising over to router 2. A little hint for you, take a look at, on router 2, at the routes we receive from router 4. And notice the path, and and then compare it to the path of the router 4 advertised subnets. And you'll see the difference. And you need to figure out why that is. Why is AS path 1 showing up on router 2? Even though router 4 appears not to be advertising that. You want to pause the video and try to figure that one out. You can see here on router BGP 4, we have a neighbor statement of a route map ADV out. And we take a look at this route map and see if you can find in your route map in your lab why that is, what the issue is. And the fact is, the issue is routes from router 4 have an AS path prepend of 1. An administrator has prepended the advertisements with AS path 1. So what we need to do is, there's really no reason that's necessary. So we're going to go ahead and just simply remove it. AS path prepending is not always the ideal way to try to manipulate BGP routing. It is a way you can do it, but it's kind of a clunky way. And in this case, it caused confusion. And you can clear IP BGP star soft on router 2 all day and it doesn't change anything. So do you know why that is? Even though we're clearing the BGP neighbor relationship. And that's important to know when you're troubleshooting. The fact is router 4 is still advertising it that way. What we need to do is, even though it's not programmed anymore, we need to soft clear on router 4. And once we do that, it will look like it should on router 2. Now there's an important troubleshooting note. That soft clear and doing it in the right place is very important. Otherwise you're going to be scratching your head for a long time as to why the issue is not going away. So here's what you've learned. We've done some troubleshooting on EIGRP and OSPF and redistribution and BGP. All of this information is going to be helpful for your exam, but also to make you a really great engineer. So I wish you the best of luck in your studies.